All right, welcome everyone. Kirkwood School District 6th grade science. My name's Dr. McGee. This is...
I'm Mr. Banwaring.
Let's talk about atoms.
Let's talk about them.
So our goal today, we want you to be able to identify all the parts of the atom, how the parts of the atom play a role in the periodic table, and then of course, since we're starting on our electricity unit, we want to talk about how that atom's parts play a role in electricity, both static and current electricity.
That's right.
So some vocabulary words here.
Yeah, you want to know the words atom, element, nucleus, proton, neutron, electron. You might remember those from our last unit, but in case you've forgotten them or this is a new unit for you, those are the words you need to know.
And if you just use the first letters, it says N-penny. Anyway.
All right.
The atom is the smallest part of any element. An atom, typically when you look for models or structures or anything like that, you're going to see something that looks just like this as a picture of what an atom looks like. So you see these sort of centralized location, and you've got these other sort of small particles kind of floating around the outside.
Right, and basically what we talk about, the difference from one atom to the next atom is when we're talking about the number of protons, neutrons, and electrons that make up that atom. So we got looking at here elements, remember from chemistry, but in case you don't remember from chemistry, remember matter's anything that takes up mass and space, and there are, give or take who you talk to, over 100 elements.
Very good. All right, you can find out all information about the periodic table. It has all the elements on there, and this is kind of an old picture because you can see we're missing that bottom row, but you get the idea that if you need to look up anything, I'm sure there's an app for that.
Sure there is. So the parts of the atom or element that you need to know, nucleus, obviously is very important. It's kind of like the center, the hub of the whole atom. If we're talking about the one model of atom, scientists disagree sometimes on what exactly an atom looks like, but we don't disagree on the parts. The nucleus, the center part of the atom, has the proton and the neutron. Remember, the proton's the positive charge of the atom. It's found in the nucleus. The neutron is the neutral charge. It just kind of hangs out. We're not really sure a lot about what its purpose, but it's there.
Now, the electron is where we're going to spend most of our time with our electricity unit. It has a negative charge, so a lot of the times when we're talking about a charge moving around in a circuit or from one thing to the next, we're talking about adding a negative charge. It is found outside the nucleus, and they are constantly moving and spinning and flowing around that nucleus. So you see a nice little picture. You've got the nucleus there in the center. You've got electrons kind of floating around the outside. Other pictures, and...
They produce a magnetic field because the actual only moving part of the atom is the electron moving around the outside. And like I said before, scientists can't agree exactly on where those electrons, because they're always moving. Imagine, think of your little brother that just can't sit still. Try to take a picture of him. That's how hard it is to try to get a picture of just an electron by itself.
Or me, I can't sit still.
Yeah, sometimes, I agree. So electrons, right. So pictures.
Floating around the outside of the nucleus, floating around the outside of the nucleus. And what's really cool is if you ever want to just take a tour, there's a really cool link right here where you can go online, check out different particles and their different lists and what they do and all that sort of stuff. You can also find out the number of protons, neutrons, electrons. Great link right here. Check it out, as well as just simply search, how do I find the number of protons, neutrons, and electrons? There are great resources out there available for you.
And remember, Ape Man.
Ape and man, gotta
That's
love
right.
that. All right, I want to take you to a little model here real quick. So I'm gonna take you to that model. Check this out. All right.
Ooh, nice.
Now what's going on here, Mr. Manwaring?
Well, what we have is we actually have a little bit of moving particles happening in a circuit. And you might remember this from previous experience or just playing around with wires, bulbs, and batteries. Of course, under your parents'
Be
supervision.
safe.
Absolutely. Don't put anything in the outlet. Not good. So what we have is direct current here, because you can see the particles are actually hitting one another and going one direction. And they're transferring energy. We have the battery, which is chemical energy, and then we have the bulb, which is producing light energy. So we have some energy conversion going on here. We'll talk about that a little later.
We'll do that later. But what I want you to focus on is I want to focus on the fact that we're talking about atoms. Now, are those atoms that are moving around in that circle thing there?
Nope. We're talking about electrons.
That's right. We're talking about electrons and electricity. So as we begin investigating more about this unit, I want you to think about each of these little blue spheres moving around the circuit. I want you to think of it as an electron, as a negative charge. Okay?
And think about it, there's a little disclaimer here, scientists, that watching this from other places, you might say, well, wait a minute, you're teaching that electrons are moving from one place around all the way back to the battery, but actually they're bumping one another. They're just hitting one another, and that's actually the movement. So this model is just a little bit off by that. But
right, but it's a good representation
absolutely.
for what we need. Great. All right, to wrap up, We hopefully introduce you the fact that atoms play a role on the periodic table as well as in electricity. And we'll be talking more about static electricity here in our next video. However, what you saw in that model was a great model of current electricity. So we'll see you soon.
So stay tuned.
See ya.